Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Today we're interviewing Jakub Kozłowski.
Hey, you did a good
Poland.
job.
Well, I've been.
10 out of
both of us
10.
have been to Poland. I think I've been to Poland. I've spent a bit of time in Poland.
Nice.
It's a lovely place.
That is a lovely place.
Yes, it is.
Welcome, Jakub. Good to have you.
Yeah, good to be here. Very, very glad that you are having me.
Yeah, no, it's super fun. So you had reached out on Twitter and invited yourself on the podcast, and I was like, Jakub, you are just like so much further ahead than me on all the like thinking of NICs and functional programming and all this stuff. I'm like, I don't think that I can have you on the podcast because I'm not going to be able to like grasp what you're going to talk about. But we can suck up some pride. And
we're good at saying, okay, let's back up and talk about the fundamentals because we're going to assume that's part of our deal.
Yeah.
No, I don't think that's true. I think it's we all know that's not true. I just happen to know some things you don't, and you probably know some like gazillion things I haven't even dreamt of.
I do feel like you and I have been on kind of similar journeys through what we have learned and where we're going with technology. It's just that you're like 5 years ahead of me. So that's what it feels like.
I don't know. I did have a late start. I didn't code until like 12 years ago. So
okay.
How old were you when you started coding?
That's okay. That's a difficult question. When did I really start? Well, when I did like my first program, I was probably 13.
Nice.
I learned Java. Well, it probably took me like 2 years to read your book. By the way, yeah, your book.
Nice, okay.
I think I first borrowed like the 3rd edition.
Okay.
I think, yeah, the one before the last, I believe, maybe. I borrowed it from a friend who's been my very close friend since basically that time. And then I met Josh Long. That's a different story.
Mm-hmm.
Yeah.
And he sort of convinced me to like fully commit to it. And I got my own book, the more recent one. I think Java 1.6 was the latest.
See, we're on the same journey because I learned Java from Bruce's book also. So that's see, same journeys.
Damn,
so
how old is that book?
Yeah.
Well, the 4th edition was, I don't know what it was, like 2005 or something like that. Whenever
6, yeah, something like that.
Whenever 1.6 came out was about when it got published, and then yeah. Well, and I just want to apologize for all the misunderstandings that I put forward in that book.
Bruce has been having some remorse about leading people astray with objects, but your PyCon presentation that
was
you
called
did,
Rethinking Objects.
Yeah, and so you're trying to set the record straight. You're trying to this is your way of correcting the damage that you did.
Yeah, trying to. I mean, and some of it couldn't have been known as damaged at the time, but it's like, well, where are we now? It's like, yeah, a lot of the functional stuff has influenced the way we think about objects now. And if you look at some of the more modern languages that don't allow implementation inheritance, you go, okay, maybe we should try that in our in our older languages, but there's still things in objects that are helpful.
Yeah.
So just not everything.
Yeah.
And not all the time.
Yeah. Not everything.
So basically not Java at this point.
Yeah, I feel the same way. Like one of the things that bugs me about languages like Haskell is like I like to group things. I like to encapsulate stuff. And I think it doesn't, like the object-oriented approach sort of makes this more seamless or more intuitive. I don't know. I'm thinking like Scala style, like just interfaces with implementations, private methods. This kind of stuff is actually the good part, but probably not the mutability part.
Yeah,
it
is interesting that again, we've been on the same journey where in Java, okay, everything's an object. Let's encapsulate state. Let's, have these ways to like access and
everything's
manipulate,
mutable.
and everything's mutable. And then after a couple years in Scala and moving away from that, there's no way I can go back like to that realm. And I'm sure I would guess that you have gone on a similar journey around that. But I don't know, tell us about that.
Yeah, it's just like you get more tools to use, and then you just decide that some of these tools are better suited to what you usually do. I guess mutability has some advantages, not just like performance-wise, which is kind of obvious. Although some languages can do immutability with high performance. I think Rock
Sure.
does something like
Rock.
that.
Yeah.
If they have if they built it into the foundation, sure.
Yeah. If the language assumes everything is immutable, then I think that's like the basic assumption that makes it possible to optimize like that. But
there are some trade-offs, like having to do the deep, like nested copy thing to get a mutation of some deep structure of objects is painful. Or you can use lenses.
Is that
but
just
then
syntactic sugar, or just the problem with immutability? Because I think you can make this cleaner with
You're right.
with other syntax, but also how do you, let's say you want to mutate a couple things, how do you chain those mutations? Then you sort of run into, do I want to model this as an effect, or do I just not model it as an effect? I'm not sure what the alternative would be.
Yeah.
So if you want to keep that sort of clean, direct style mutability for some reason, maybe for some DSL, then maybe there's no better choice.
Yeah.
I guess that's still a valid use case for mutability, maybe.
But I think you're right. The languages, if they wanted to, could give you the programming experience of mutability without the actual mutability. And we've seen hints of that with Rock. Flix has done some of that, and I would guess Unison has done something around that, but I haven't looked closely at what Unison has done. But yeah, it's like there is a convenience to mutability. It just comes with some trade-offs.
Rust is very interesting because its default setting is immutable, but if you need something to be mutable, you can make it that way. And it's like a pretty interesting balance point. It definitely pushes you towards immutability, but doesn't force it on you.
Yeah.
I saw someone say Rust's mutability is like, the stuff is mutable, but it seems like it's not, because of how well controlled it is, the access to mutating stuff.
Yeah, well, it's like I don't know. I just, as I learn
with
it,
guardrails or something.
Kind of. The more I learn it, the more I look at every decision that they make, and I go, "That's a smart decision." And in this case, they're going, "Come on, everything's in RAM. It is mutable, but we can put the guardrails around it. If you want to make it, if you need to make it mutable, then you can. But otherwise, the default is nope."
Yeah.
And it's like, oh, that's actually a really wise decision, I think.
Yeah.
Yeah. So
I think this goes beyond just language design as well. Whenever you make any kind of tools, if you want to have like a sane default for everyone, and like an escape hatch to the more sort of unsafe world, like the unsafe keyword in Rust, I think that's one way to do it. You can also be like, here are all the features. You can use any ones that you like and make your own subset of the ones that you consider safe. I think the latter is more like the Scala approach, where we sort of have access to everything, and people can create like linters or compiler plugins to disable or guard against certain features.
Yeah.
But
having the power, but being able to reduce the power for specific use cases or in specific ways, I think is an interesting balance.
I had a big aha moment when I was reading the Red Book, functional programming in Scala. And when I got to the point where they were talking about recursion and how they said, okay, so make everything immutable. And then when you look at recursion, you go, oh, every time you recurse, you create an immutable stack frame. And okay, that makes sense. And then when they said, all right, so tail recursion optimization, inside that little box, they swap it with something mutable. And you go, wait, this violates every principle. But then you look at it and you go, no, it's carefully constrained inside that box and it's not visible. And I think they even made that point. They go, as long as it's not visible outside the box, it's okay. And it's like,
Yeah, the only way you can see it is if you look at the bytecode, I think.
Right.
So that's perfectly fine by me. And I think it's just like a simpler example of what Rock does. I think there was this example from a strange loop talk or something like that, where the quicksort was implemented to be almost as fast as C or C++ and faster than Go because and it was an immutable implementation.
This is in what's his name's strange loop talk
Richard
on
Feldman.
Yeah, Richard Feldman's talk on Rock. Yeah, and it was like, oh, so performance isn't actually the reason for why you should be mutable.
And I hear this argument like all the time. It's like, all the time is an exaggeration, but some people say that immutability is bad because the world is mutable and it has to be reflected in the code, and ultimately it's just going to be bytes and memory and all of that, which is mutable. But the counter argument is obviously, why do you have to leak all that into your code? Your code should be an idealized model of what you're doing. And why don't you make this extra sort of layer of abstraction to make things easier for you? Just to fit in your
for
head
me,
easier.
Immutability creates an ability to understand code execution in a linear way, where with mutability, there's no ability to know. You eventually get to the point where you have to understand the underlying life cycle of how things are mutating to then be able to assert expectations around some piece of logic. The classic example for me around this is Hibernate, and how Hibernate, it just magically at seemingly random times is mutating your objects. And so you have no ability to know, am I looking at this object at the right point in time? And with immutability, you never have to think about that because it is just a total linear flow of
it's another example of how constraints are liberating. It's just like, okay, go-tos. Well, I mean, the real world, things are jumping around all the time. Should we model that in our code? Well, it turns out that it's much more liberating to have the constraint of keeping everything in a function, single entry, single exit point. And even with effects, we see that amplified even more. Never jump out of the middle of a function with an exception or modify it's like, oh. And then once you start doing it, you go, I can do more now because I don't have to think about that all the time. So, but should we? I'm curious.
The same
about
with things like sorry, just one last point.
Yes.
It's the same with like for comprehensions or for loops. You don't actually have to have like a for loop where you iterate with the I variable aptly named. We all know that's going to be in the implementation, but you can also sort of hide it behind the for each or any other method like this,
filter, whatever.
It's just like a layer of abstraction to help you think about it.
Yes, but I mean, in C, you got to have that counter even if you never use it.
So I don't know if I've said this on the podcast, but I've been trying to push this idea of mutability being the $1 trillion mistake, because you've heard nullability is the $1 billion mistake. I do really believe that mutability is the $1 trillion mistake in the last 40 years of programming, because I think so many bugs in our systems, the foundational issue underneath so many of them are mutability. And part of my proof for this is that 90% of the time when somebody posts some like programming puzzle on Twitter or in a coding interview, whatever, like, tell me what this program is doing. 90% of the time, it's got mutability in it because you can't freaking understand what's happening in the program.
Just 90%?
Maybe 100%.
Yeah.
Yeah,
99.
mutability is just the trick question. Whenever I see this on an interview, like I know they're trying to trick me.
So the answer to all of those is, oh, what's wrong with that program is it's mutable.
Exactly.
Yeah, obviously.
Exactly right.
Next question,
Next
please.
question. Let's make an immutable version, then we can talk about it.
Yeah.
Well, it can be a legit answer because maybe
sure.
the interviewer is trying to find you, trying to make you find that there's like pointless mutability. This could be immutable.
Yeah.
Mm-hmm. Yeah. The first time I started playing with it, and I was writing some kind of Python program, and I said, "Oh, how would this look if I didn't mutate things? If I created every time I wanted something new, I created a new thing." And one of the first things that I discovered is, oh, I have traceability. Now I can look at each one of those things. Just that one simple thing. I could just look at each.
That linear sequential.
Yeah, and I could go, oh, that thing which never changed. I can see what its value is right now. It's like, and the
refactorability,
right? And then
just using a debugger, not even with time travel like an Elm, but even just a normal plain Java debugger, it can also just save you some time because you don't need to think about, oh, now it's a different value. Now it's something
different.
else.
What caused it to change?
What caused it to change?
Yes.
That's exactly it. With immutability, there is never a question of what caused it to change.
Because it was initialized, and you know exactly where that was. Yeah. It's it's a really interesting mindset change to go through.
Yeah.
Because initially, like when I saw Java code and everybody, what is this doofus putting const everywhere? Why are they bothering with that? That's just confusing me and making the code noisy. And now I look at it and go, well, of course, they knew and everybody else didn't.
Yeah.
It reminds me a bit of the public keyword in the beginning of my Java adventure. I was like, why do I have to add public to everything? Why isn't it public by default? And then Scala came along into my life, and I was like, oh, this is great. Everything is public. I can use everything again.
Yeah.
And then I started writing libraries, and I realized public was the wrong choice and the wrong default, and I don't want it anymore. I just want back, like, I actually would like everything to be private by default as a library developer.
Yeah.
After 20 or so micro libraries, it just makes so much more sense.
It is,
but it's a different perspective from like a usual application developer.
Exactly. Application and library developers have different needs, and we, I think, have tended to lump their needs. We tended to assume that their needs are the same, and I think that actually relates to the object-oriented piece too. Is that a lot of the needs around object-oriented programming are for library authors, not necessarily for the application developers.
Well, I remember when I was on the C++ committee. I remember Bjarne saying, our goal here is to make library creation easier. Well, no, he might have said library use easier, but I would say, the focus was on libraries. And, if a language has a large bunch of libraries, that's ultimately what makes it successful, I think. And if they're easy to use. So So let's talk about your the presentation you just gave on Smithy.
Yes.
Is that what it's called?
Yes. So Smithy is a language made by AWS. My understanding of the history is that they had a bunch of services, which is clear if you just look at the console. They have a lot of those, and they wanted some sort of standardized way to define the interfaces for those, so that they could generate SDKs and multiple languages and probably use them internally as well. And there's a talk by, I'm terrible at remembering names today. Michael Dowling, I think, is the principal engineer who leads the Smithy team. He gave a talk at an Open API conference virtually to just like discuss what they made, why they made it. I think they used it for like 6 different languages at the time, which was like 3 years ago. Might be more now, but they surely use it for Rust, for Python, I'm not sure, and for Java and Node, I think they do use it. But So they came up with this language. They had some earlier iterations. I don't know much about those because they could have been internal. But right now it's like an open source language. There's open source tooling with a reference implementation in Java for Java build tools and Java based build tools like SBT. They don't support SBT explicitly, but we can
You can
piggyback
add it
on
on,
that.
yeah. So
And
Smithy
mhm.
was created as a way to define an interface to services. Is that?
Yes, and one of the things that Smithy makes like a point of is that not all APIs have the same kind of flavor. They don't all follow the same protocol. It doesn't have to be just like, even if you assume everyone is using HTTP and REST and JSON bodies, then you cannot always assume that they're going to represent the same concepts in the same way, like union types. You can have unions that are tagged, where you have like a single top level field that discriminates the subtypes of the union. You can have a that was tagged. You can have a discriminated union with like a discriminator field, or probably the worst of all, you can have untagged unions, which is like, I tried to decode this whole thing. If it doesn't match, try the other thing. And there are pros and cons of each of those, but regardless, some service
how do you
might
create a
say
language?
that it
How do you create a
that
language
supports
that
like
is able to like
all these
be
cases.
represented?
Exactly.
Yeah.
And then there's, on top of that, there's like, I think AWS has at least one protocol where there's basically JSON RPC in the bodies. So you have like maybe a single endpoint where you send everything to, and you have the operation, like endpoint name in the body or something like that.
Yeah.
So to support
The
all
old
these things with the
SOAP,
same language.
was that old SOAP protocol where it would just like XML RPC or something in SOAP bodies? Like that sounds similar to that. Like just like,
I have not
we're
seen
gonna have
that.
this like envelope structure. Give us whatever you want in that envelope, and in the body, we're gonna tell you what we want to do, and we'll let the endpoint decide what it wants to do with it or something.
Yeah. Well, the thing is, they needed to keep backward compatibility. I think some of these services have been around for like 20 years. S3 probably is very old. So and it has like its own protocol. So in order to support all of those with the same kind of language, they decided to make the language itself protocol agnostic. So what that means is that you don't only not standardize on like HTTP or whatever kind of transport you're going to use. That also applies to serialization and some semantics of what can be retried, what can be cached, and so on. So the base language is actually very small. It has just a couple of primitives, and you define your services in terms of operations and your operations in terms of inputs and outputs. That's basically it. So just like a pure Java interface with methods that have an input type and an output type, just POJOs.
So
That
this
would
is
be like
more
a
of a
representation in Java of the Smithy interfaces.
this is more of an interface description language then. It's not like a full-on
Yes.
language.
Well, so that's the sort of like I like to call this like levels of Smithy, how deep you go into Smithy, into specifying your stuff. So this is level 1. You just have these Smithy types, which are sort of like POJOs and interfaces dealing with those. And then you have the
So wait,
second level, which
before you
is
go into level 2, at level 1, it sounds like there's primitives. There's way to model a function, essentially, like something that takes inputs and returns outputs.
Sure.
How do you decide how much should be in that IDL at that level? Because you want, I don't know, a string type, you want some numeric type, multiple numeric types,
Composite.
booleans, and then maybe the ability to create composite out like new
Right.
types
So these
from those types.
exist on that level. There are structures, basically case classes. There are unions, like we discussed before, but they don't constrain you to a specific encoding yet. That's still not a thing on this level. On this level, you
Enums?
just have like unions. You also have enums now.
Okay.
This didn't used to be a thing in version 1 of the language. You have you can create like your own string types, basically new types. And there's like the whole tower of numeric types, and a document type, which is basically like a JSON type, sort of like a
Okay.
catch-all for an arbitrary structure.
And then some types? Is there some types in Smithy?
There's just union types. So going on a tangent here, so one of their goals in AWS was to make code generation from this language very easy to do. So there's also like lists, and there's maps where you can have like typed key and typed value. But one thing that was sort of interesting to me in the beginning and kind of puzzling why they did it, you cannot have like an anonymous list of strings. You cannot say my operation input is a list of strings. You actually have to create a list type called like strings and say that the member of this list is a string. So you can have multiple list types that target a string, but they are different types and they each have a different name. And that sort of helps code generation, because when you generate like any kind of schemas for those types or any kind of encoders, you have like this separation. You don't have like context aware, oh, this list of strings has to be serialized in this way, this list of strings is serialized this way. You just have string lists, name lists, and these have sort of their own schemas inside. That's also important because you can have like metadata, like this is a non-empty list, so that you can encode that sort of into the list type and not into a list of with some metadata.
I've been fascinated by the IDL, like what's happening around language development at IDLs, and what I don't understand is like how do people think about how much should go into the IDL? Like, should it have generics? Should it have macros? Should it have the like constraints, like non-empty list? How far do you take an IDL? And that's where I think it gets confusing, because at some point, aren't you just creating the type system of Scala?
Yeah,
right.
Yeah, it's very much like a trade-off of what you're aiming for and how much you want to support on that level.
Who your audience
Smithy
is.
just shows a particular set of trade-offs, exactly like what you're going to do with this and who's going to use it. And I think they made a language that can be used outside of AWS, which is great, but also it has enough features that is useful. Like, it's not that generic that everyone can use it, but it's concrete enough that it's useful to people. It's generic enough that it can be used outside of the AWS. It's not as generic that everything can be done with it.
So would this be on the same, like if I was looking to solve this particular problem, would I say, oh, I could use Smithy or I could use gRPC?
Protobus would be, or
common question.
gRPC, you're right, would be probably the more direct comparison with the service side of it.
And how, what problem does Smithy solve that gRPC doesn't?
I think they still have a similar problem. I haven't actually seen anyone do gRPC without protobuf, and I'm not sure if that's a common thing to do. As far as I know, the documentation, at least, I did some research for the talk, but the docs strongly encourage you to use protobuf internally, and the tooling probably assumes some of that as well. But I'm not going to assume this because I haven't actually used it in real life. I think it's just like Smithy's. It doesn't have any default implementation, any default protocol, so it cannot assume any standard protocol. Unlike gRPC, which sort of has a default, and probably that's going to be the majority of the usages.
So could you use Smithy with protobufs?
Yes. So there is a translation from Smithy to protobuf made by Disney. It's called Smithy Translate. That there's a bunch of more stuff in it, but protobuf is one of the targets. I haven't used it, but Disney has some teams. I used to work for them, but still used to calling it we. They have some of that running in production, so it's useful.
So stepping back just a second on IDLs, the goal of IDLs is we have two different systems, and we need to make sure that they can communicate and have a contract that ensures that their communication will work correctly. Is that
That's
the
one
purpose
of the
for
goals,
IDLs?
I think. So for me, it's about efficiently working on communicating services in an organization. If I were to use this, if I were to build something like a couple services on my own, I'm not sure I would pick an IDL for this. If it was just
Mm.
the same language like Scala, I would probably use something like Tapir because it would be so much easier to set up and actually far more flexible because it's you define your endpoints in Scala. You define your
Yeah.
endpoints with any kind of logic that you want. You can create custom like middleware and so on. Well, you can do that
So if you
in
control
Smithy to
both
some extent, but
sides,
yeah.
Yeah, what
if
kind
you
of boundary are you crossing that requires an IDL and this system?
yeah, so if you control both sides of the communication, then you don't really need an IDL because you don't need a contract. You're in charge of the the communication.
Mhm.
But I think in the case of IDLs, you're saying we're going to define an agreed shared contract so that both sides can communicate without having to have centralized control of that communication. Is that right?
It sounds okay. I thought of it as, because way back when Corba was getting started, it it was like, okay, you're dealing usually with different languages, and you need to
Mhm.
have some sort of common contract. Yes,
Yeah.
And the generation of the code for that is messy and complicated and easy to get wrong. So it seemed like to me that it provided you this higher level abstraction that you could write that and it would generate the code for you and not get it
Mm.
wrong. That felt like an
Mhm.
important part.
You're right. Yeah, the polyglot side of it
Mm-hmm.
is, and then I think there's another side of it which is protocol evolution.
Mm.
So let's
Mm-hmm.
just assume that at Amazon everyone was using Java, and so they didn't have to think about the polyglot side. The thing that they would still have to think about is that one service, you can't rev every single service in the organization all at the same time, and so because of that you need to be able to evolve a protocol without the attachment to versioning everything globally. Is an assumption that they a reason why you would need the IDL even if you had all the same language.
Yeah.
Is that true, Jacob?
I guess I didn't consider that point very thoroughly. For
I,
me, it's mostly the use cases. Of course, like multiple languages is a great example of why you might need something like this. But also having a centralized space like an API registry where everyone puts their APIs is another great thing. You could have probably like a Scala repo with all the endpoints, and everyone will be pulling a library from that. But that just brings in another bunch of issues,
Yeah.
like binary compatibility and so on. And
so the having the ability to publish the contracts into a space where everyone can know how to consume that contract and work with that contract
version it.
and version it.
Mm-hmm.
Yeah, that seems.
Yeah, and then you can
good.
enforce certain standards for the entire organization, like a certain way of versioning your APIs, your endpoints, or you can pick a concrete like union encoding for everyone. We actually did this. I'm working on a team that maintains such a registry, and we actually picked just tagged unions, the default from Smithy, because it's first and foremost, it's the most efficient if you are going to decode this, because you only have to read one field out of the whole payload to know which kind of subtype you have.
Yeah,
and also more tooling works with that because it's the default assumed, not assumed by Smithy, but it's sort of built into the Smithy language that unions get this kind of encoding. You can opt out of it, but it's there.
Yeah.
So I want to get back to the levels to maybe provoke some more questions.
Tangent on.
So
on
level
IDLs.
1 was just like pure types, and you could define this in like a DSL in any other language, Well, all of this you could define in a DSL, but the point is to have a language that's not a general purpose programming
Agnostic,
language.
yeah.
Yeah. So level 1 is just these structures, and then you want to add some semantics like I want this to be sent via HTTP with a RESTful interface. So then you slap on a protocol on your service, and then you say, this service can be interpreted as a REST JSON service, or this service can be interpreted as a JSON RPC service. And that's, to me, like level 2, because you're giving meaning to these types that you defined. You're giving yourself or your tools a way to interpret those into something runnable, but you're still not specifying like the details of like this endpoint list at this URL, this path, or this parameter is a query parameter. And that's sort of like level 3, where you can attach extra metadata to any kind of operations inputs, which sort of has to work with the protocol. The protocol can also enforce certain additions. But yeah, you just add more information so that like Smithy tooling doesn't have to derive it. You can sort of like specialize. This is what I want. Please don't change it for me, which it also helps you maintain compatibility and clean interfaces. Even for people who are not going to use your Smithy specs to generate code, it would still look like a normal handwritten REST API. Even though it could be completely generated from Smithy with the metadata.
So Amazon built this for themselves. They likely use it internally to interoperate between their own services, but then they generate their SDKs around it. And then do they also expose, like, can you take do they publish their Smithy definitions for their services so that then you could also, if you wanted to, generate your own client and talk directly instead of going through like their client library layer or something?
Yes and no. So Smithy has like 2 syntaxes. One of them is the IDL, and then you have like the serialized version of it in JSON. They have a repo, I think it's the Node.js SDK, where they have the JSON files for all of their services. So you can still use standard Smithy tooling to read that, to decode that and generate code or whatnot. But it's just not it's not very official. It's sort of like
they don't
you have to know that it's there.
They don't have like a public repo of their IDL files.
Yeah, it's not documented anywhere on the Smithy site. You sort of have to reverse engineer it. But based on this repo as a baseline, the Smithy for us maintainers, well, Olivier, who's the main engineer behind Smithy for us. By the way, I think you should also talk to him.
Oh, awesome.
He built sort of like a pipeline.
Is the Scala piece of Smithy.
Yeah, right. Yeah. It's like a Scala specific entry point to dealing with Smithy. We can talk about that in a sec. So one thing he built was sort of like a pipeline that takes these JSON files of the AWS specs and republishes that. Sorry, first it translates that back into the IDL so that you can. Well, it's easier to read for humans, so that might be useful. And then you can. Then it also packages that up into jars, which is a common thing to do when you want to distribute these specs.
Yeah.
And then you can pull that into your Smithy Forest code gen to get like the code generated for you.
Yeah.
And there's actual client implementations of some of the AWS protocols in Smithy for us, which enable you to actually call these.
Yeah.
So I have a meta question before we move on, which is, instead of creating an IDL, would it be possible to take each language and constrain it when you were generating one of these interfaces? It's a lot harder, I agree, but I mean, it seems like it'd be possible to say, okay, so we're in Kotlin now, and while you're writing the IDL, you can only do these things, and we'll type check against that. Yeah, bigger problem, probably something I would want a large language model to do for me, but it would be possible, right?
to define your
Probably,
IDL
yeah.
essentially in a constrained general purpose language.
In whatever language you were using, so you didn't have to learn a new.
So I feel like I actually saw someone a
I think
while
it's
ago
been done before,
experimenting
yeah.
with this in Scala, like using Scala as an IDL language and then making it so that you could then output your contract from some Scala code. And I don't remember the name of this project, but
is it runtime though or compile time? That's the big question.
I think it was compile time.
Yeah, I would think compile time is when you'd want it to happen.
Yeah, but I'll have to go.
Anyway,
see if I can
it was
find
just
that again.
a tangent.
Well, so that when I first started working with protobufs and gRPC, that was exactly my thought. Was I don't want to write this in this other IDL. I want to write the definition in Scala. Because that's what I'm familiar with, that's what I'm comfortable with, that's more power. And then I can, from that Scala code, generate the IDL contract that then gets used for the other clients. But then I later realized like how that falls apart is because you want, the whole purpose of the IDL is to have the source of truth be the agnostic thing
that you
so
can
other
give to
people don't have to learn your language.
That's right.
Right.
Yeah.
Sure. Okay. So there's a logical reason for that, not just it would be really hard to implement that in all these different languages.
And it's not just your programming language. If you use any kind of library for this, then the other people would also have to learn your library and any kind of utilities you built on top of that library if they wanted to review this. So I like Smithy. Well, one of the reasons I like it is that it's easy to read and write for humans. You don't actually need some sort of specialized IDE, although there is like an LSP server and the
language is very simple, very constrained.
Yeah, it's very easy to read, and I think that just makes it good for collaboration. yeah, you could. So it's great for collaboration, even with people who are not well. I don't want to say like non-technical because that has never probably been the goal of any kind of IDL. Probably some IDLs made this a point, but in the case of Smithy, it's just like it's a low barrier of entry to read that because it's sort of a natural representation of your services. It might be a bit tougher to write it if you don't have a tech background, but
I guess that's a good point of the goals of an IDL is to make a language that it doesn't matter if you're a Scala developer, a Python developer, a whatever developer, you should be able to look at the IDL and without any knowledge of the language, actually be able to read and write the IDL. And I
you can just reason about what's happening with just a couple lines of introduction. I actually liked one cool thing in Smithy again is that you can separate out the sort of level 1 info from level 2 and 3. You can sort of have these in two distinct files, and only when you sort of run the code gen, these files will be gathered and combined into a single model. So you can keep one file with just like the pure input-output stuff, and then one with the extra annotations. So that I'm trying to encourage people to collaborate first and foremost, like just look at the input and output. Is there all the data that I need in this input? Is everything, am I able to provide all these fields in the output? Things like this, and not bother that much with like which endpoint this is going to be. Is this going to be a query parameter or is this going to be part of the body? Of course, they still need to answer those questions, but maybe later.
Right. So it's interesting that they have thought about the layering and how there's different concerns at different levels, and not having to lump all that into a single definition is helpful.
Yeah, not exposing all of the details just to everybody. So, because then maybe you could show it to somebody who wasn't as versed, and they could go, "Oh yeah, those data structures make sense," or "Oh wait, wouldn't you want this piece over here because of some business need or whatever?" So,
So I think
it's a two-sided coin, because the other side is that suddenly, like when you have I would like to show it, but when you have like just the data input, data definitions, and then you also have the HTTP semantics on top in the same file, you can sort of like skim through one file and you see what operations are there and what HTTP endpoints they correspond to. So it sort of looks like a Swagger UI, but in like text, not in a visual form. But when you split this up, then you lose that nice experience of just seeing everything in one file. So it's sort of obvious, like the decomposition problem, not just specific to IDLs, but we also have to be aware of that.
I would guess that they would be able to provide like a JavaDoc tool that would be able to take the full IDL, all the layers, and roll that into like a documentation site like Swagger or something does.
Sure.
Maybe
there
that
is
doesn't exist, but
it's part of the standard tooling that you can convert to OpenAPI, so you get Swagger UI sort of for free. Of course, that assumes that you are an HTTP protocol. You're using an HTTP based protocol,
right?
And if you have any kind of deviations from the sort of standard protocols that they have, you have to customize the conversion as well, which also applies to any kind of interpreters you make, because again, there could be differences.
Yeah. So I do want to take a quick tangent on OpenAPI and Swagger, because I think we should point out there is another approach that I think is more popular in this realm, which is more similar to what you were talking about, which is you write a service in, let's say, Scala. You then can generate the service description from your code and publish that service description to some website, whatever, and then that just becomes documentation for how people use your service, but there is no shared contract. And this is the way that I think most people do this, which has some benefits. It's simpler, but there is no shared contract, and I think that that's a critical difference.
I also think it doesn't always work very well. It really depends on the kind of framework you use. If you just slap on annotations in, let's say, HTTP or HTTP4S, I don't think you're going to get very accurate information at all times in these specs. And to me, bad documentation or inaccurate documentation is just worse than having none of that at all. If I know that I cannot trust the docs, then I would rather just look at the source code for the source of truth. Yeah. Instead of trying to read the docs which may or may not be correct. So that's, to me, like a huge selling point behind having a declarative, machine readable contract. And if you just write, many of these DSLs are just not it. On the other hand, things like Spring Boot, I think might be easier to analyze this way, because it's like going to be an annotation on a method that has a return type. And you don't have this kind of constraint in some of these DSLs that are more like fluent DSL builder like style.
So the approach with Swagger and OpenAPI is you write your service, and a tool will attempt to generate a description of that service so that anyone that wants to talk to that service gets an idea of how to talk to that service.
Mm-hmm. But you can also go the other way. There's an OpenAPI generator, where you can bootstrap your project from that. But for the Scala side, at least, last time I checked, it was sort of more like a bootstrapping than something that you would run as you develop and extend your API. It's sort of something like you run this once and never rerun it again. So your implementation will eventually diverge from the definition if you don't.
What's your source of truth?
If you don't very strictly check that they are in sync.
Yeah.
Which I think is a tooling problem, not a human problem.
Yeah. Yes. Yep.
We were going to ask about WASM.
See, that's exactly where I wanted to go. So it's fascinating that we've seen this kind of emergence of IDLs becoming a bit more mainstream. And the place where I've seen this emerge most recently is with WASM and the WASM component model. And so it's fascinating to me that with WASM, they're like, okay, we have different WASMs potentially created in different languages, and we need some interoperability model for this. And so the WASM component model is creating their own IDL to define the way that you can talk WASM to WASM. And so I've just been, again, fascinated with this idea of IDLs seem to be becoming the way that we tackle interoperability challenges across services and now across bytecode programs, essentially.
Well, it just makes
And
sense.
these kind of interfaces could also be generated, right? Like the compiler or whatever outputs these WASM files, I guess, might also generate that kind of specs for you.
Well, yeah, certainly in strongly...
It's just FFI, right?
Yeah, a language which is really strongly typed like Rust, it seems like, sure, it could do that because it knows everything. And Scala, we would hope.
Yeah, I mean, I think that there's kind of what we talked about earlier. You can make your source of truth your code or someone's code and generate the IDL from that that's the shared contract. Or you can make the source of truth the IDL and then generate whatever implementation you want.
I wonder what the advantages of each would be. Simplicity if you start with your code and generate the... But it just seems like the IDL... writing the IDL seems like that would be the, I don't know, my intuition would be that would be the way to go, because then you're thinking about contracts across systems and languages and stuff.
Yeah. Sometimes it also happens that a language or a certain library sort of encourages you to model your APIs in a certain way. Like there are these idioms that are just more convenient in that DSL or that library, like a certain union encoding. Well, which isn't a great point because Smithy does assume a default, but still, sometimes it's very difficult to customize that. So whatever you start with, whatever you get as a default, maybe like with Jackson in Java, is what you get in the final API. And you're not thinking API first or a contract first. You're thinking in terms of just your code and your classes and your domain. And sometimes also leaking your domain details because you didn't consider what should be public or what should not, or what should be in the data transfer object. Or maybe you don't even have a DTO. Maybe you just share the types with your API and domain and database and all that, which is probably good for prototyping, but not for a mature project, I think.
Yeah, and that leaking I have a problem with, just because if I see something, I'm going, well, it's out there for a reason. I wonder what that is. And if it's just because it randomly leaked, that's just going to be confusing.
Yeah. So it sounds like you've spent quite a bit of time with Smithy. Where's the world of IDLs and service description languages? Where's this all going?
I really don't know. It's kind of hard to predict, but I can tell you where the Scala side of it is going, because we still need to catch up to some of the things that exist in the Smithy world that we don't have on the Scala world. Like supporting all these AWS protocols would be really nice to maybe have a new generation of SDKs for AWS. Smithy 4S supports Scala Native and Scala JS, so you could have an SDK that works on all of these platforms based on the same code, and it just runs on any kind of platform. Maybe for Lambdas or anything else. So yeah, there's a lot that we can still do, and the library design or the kind of things that we can generate from these specs, that's an open question, and we can still get more. I've been working on and off for the last year and a half on something like a playground for calling Smithy services. So kind of like you have GraphQL Playground or GraphQL, kind of like a Swagger UI, but in a more protocol agnostic way. Currently there's an LSP server, so a VS Code plugin. So you can write your queries in a protocol agnostic way. You just deal with these inputs and outputs, well, mostly inputs. And you can execute that as a query, provided the server understands that protocol and can execute that. So far, it only supports AWS protocols and the simple REST-JSON protocol, which is sort of baked into Smithy 4S. But yeah, I have some ideas for evolving this if I have the time to spend on that, then surely it could evolve into something bigger. There's also some similarities with like Postman, because you can have these scripts where you can like maybe make one call and then grab the result, pass some of that to another call. I don't have that yet, but I would like to have this make this a sort of scripting language for Smithy APIs eventually, so that maybe you could run some regression tests or smoke tests using the syntax of Smithy and not using HTTP. Well, not the syntax of Smithy, but the vocabulary of Smithy and just Smithy specs, rather than curling a specific HTTP endpoint with some parameters and headers.
Yeah, I mean, like Bruce was saying earlier, having the constraints of an IDL, I think, does open up a lot of opportunities for better tooling. So you've mentioned a number of great things that could provide significantly better tooling for developers around Smithy. Another one that I think about is, why not be able to feed in a Smithy definition to ChatGPT and have it generate sample data, so that then you can use that sample data and while you're building your app or something. And that is a whole lot easier with a constrained IDL than it is with a general purpose language. So I think there's
you don't even need something like a ChatGPT for this, because you could probably generate all these examples just like Swagger UI does. We could sort of reuse a lot of that. I actually saw, this is like a huge tangent, well, quick one, but when you have a Swagger UI representing a spec where there's a string type that's a regular expression, it can generate an input that matches that regular expression, and these can get so long. Like one time I saw a regex for email addresses, which probably shouldn't be done, but it was there, and there was like a 16-line long on a widescreen monitor example of a payload that matches this regex. It was incredible. Now imagine this, but for like property-based testing, like for any arbitrary validation, that would be something, and probably something that language models could help us with.
Are there test frameworks for like Smithy, like to help you test your IDLs?
I'm not sure what that would look like, but there are several ways that you can test without sort of looking at the Smithy. Test without implementing the details. I'm not sure if you meant this, but like how you can test your services written with Smithy. So because you can generate code that supports both the server and the client, you can generate the server and then for your tests run, like interpret that to a client as well and just call that. But then you are not testing like which actual HTTP paths are being called. You can do all that in memory. Like if your HTTP client server can work together in memory, like HTTP4S. But you could probably there's nothing stopping you from just calling it with curl or any kind of HTTP client if using HTTP.
It is an interesting question, though. It's like we certainly could generate the implementation from the IDL and test the implementation to test the IDL, but would there be a valid, interesting use to essentially write tests against the IDL directly?
So that also kind of exists. I think I know what you mean now. You can sort of add tests to your spec so that you say, like, for these abstract inputs, not serialized, just like a structure of my input. This should be encoded as this exact JSON, something like this, or for this input, this URL should be called. So it kind of exists, and you don't even need to have a running service because it's a matter of testing the sort of the protocol, the protocol's understanding of your spec. But and Smithy4S has support for this already, but it's sort of not very well documented or very highly used yet. But it's actually in active development, like this kind of testing. And this is used to test the implementation of like interpreters for a given protocol. And AWS, for example, publishes their with their protocol definitions. They also publish some of these tests, which we can and we are using to check that we are actually doing the right thing on the client side.
Huh.
Without without an upstream that we call, so that's far more efficient.
Yeah, if you're writing one of the implementations of Smithy, like one of the code generators, essentially, you want to be able to test that your implementation is correct, and so that makes sense.
Yeah. So I want to talk about like that protocol specific code generation, like how that works when you have multiple protocols and you generate code. So there are kind of two approaches here. You can generate protocol specific code. Like I will generate an HTTP client with HTTP4S that uses this protocol. I will generate Kinesis consumer that uses this protocol.
Yeah.
And you can go this way, but then you sort of like have an explosion of protocols that you want to support. Like you have to multiply the protocols that you want to support with all the technology that you want to support. So for different HTTP servers, you will have to have an extra code generation, like plugin at least.
Yeah.
So you quickly have a growing amount of code generators, which are not that easy to write because it is an open problem. Like it's not something that you do in one day to implement the code gen for a language. Oh, and also you have to do this for every language, like every programming language.
Yeah.
So there's the other approach that you generate protocol agnostic code and you sort of stick to the same principles as Smithy, the language, does. And that's what Smithy4S does. For example, the SDKs of AWS, I think, are protocol specific generated client code. But Smithy4S goes the other direction. You generate protocol agnostic code. So you have like case classes and Scala services with like a polymorphic effect. That's a design decision, like Douglas Final style.
Yeah.
And alongside, next to these definitions, you have the metadata. And that's available to you when you write an interpreter, which you do sort of in user land. You do this in Scala. You don't do this you don't generate an interpreter. You generate just the model and the metadata of that model.
Yeah.
Then you write an interpreter and you have access to this, not even with reflection. Well, I don't want to say it, but it's based on implicits, but it's like just type class derivation, kind of. But there's no macros, no reflection involved. It's basically just interpreting at runtime, but sort of at bootstrapping time. So you usually do this once when you start your application. You check if you are using an interpreter that actually, like the protocol that the interpreter supports is actually supported on the service. You want to do these kind of checks.
Yeah.
But for many things, you can rely on validations that were performed by the Smithy tools before the code generation.
It does seem like there's this really interesting connection between IDLs and functional programming in that you can go from your IDL to a pure functional data model, just data and functions. And then the implementation, when you need the implementation side, you just type class that into the or like next to the model, and that's how you then connect the implementation with the data. And it seems like IDLs are really well set up to, or at least the IDLs that I'm familiar with are really well set up to give you that model. Yeah, I don't know. It's fascinating that IDLs have that foundation that connects so well with the functional programming concepts that we want.
Yeah, I think it's mostly just the declarative style of everything. When you have this whatever you are trying to model, whether it be APIs or something domain specific, if you have a declarative way to do that or something that outputs a declarative view, like a data structure, then you can do everything with it. We know how to manipulate data structures, how to create them and modify them and multiply and do whatever kind of transformations with functions, with pure functions. So it's a huge space of possibilities, not just for IDLs. I think it's a vastly like under explored space of what we can do more declaratively. And I'm excited to see where this goes.
Would you say that a way to represent this in functional programming is that your protocol is a type class effect that sits next to, or that type class is onto then your data model or something.
You could think of it that way. Yeah, it would be sort of like a type class with like a dependent type, sort of, because the sort of effect of interpreting the protocol can depend on the protocol. Like for HTTP protocols, you could interpret to I/O because you just run that, assuming you have some sort of client implementation. But you could interpret a protocol annotated service into just a doc, into just a Swagger UI page. So then I'm not actually sure that would be the way to go, but yeah, maybe.
Yeah, interesting.
There's so many outputs of interpreting a protocol that I'm not sure it can be like this kind of interaction can be captured in the type class. It would,
that's true.
A bit more.
Maybe the type class is not it's too constrained of a model.
Maybe something more like a type family from the Haskell world, but I'm not sure about the limitations of those.
Yeah. I guess the effect side of it though is interesting because your protocol is where the effects are needed, but your data model shouldn't have any effects in it. And so being able to have that separation of data model versus the effectful pieces, I think is a very valuable thing that you can get to easily from an IDL. And maybe Scala is the only place that this has been explored with Smithy for us. I don't know if
I haven't seen anything like this really. This is the idea of like schemas, because you get this sort of thing named schema when you generate. Let's say you have a structure in Smithy, you will generate this into a case class. Alongside the case class, you will have an implicit schema of that type. So this has been explored before in libraries like Xenomorph, I think was the name, and there's something similar, Zeoschema.
Zeoschema, yeah.
Same sort of the same idea that you have sort of description of the data type that can be interpreted into something like a JSON codec or a description like a string. But here you go sort of all in, and you do this for entire operations and sets of operations.
Yes.
So it's probably not new in the whole like field of computer science, but in the Scala world, I think this is a huge innovation, and I'm very happy to see how it evolves and how it has evolved over the last, let's say, 1.5 years since before it was published.
Yeah.
And people seem to like it. Like whoever has tried it, mostly positive experience.
That seems like a good note.
Yeah.
Before we go,
yes,
do you have any questions you want to ask us?
It's a tough question, but I guess I'm interested in how you see this podcast evolving in the next, let's say, year.
That is a good question.
It's a good question,
because I don't think we do.
Yeah.
we're just kind of making it up as we go along. Yeah. It's mostly, I'd say the biggest evolution we had was at the beginning, we were just talking to each other about stuff that we found interesting. And then at some point we sort of ran out of that and decided
it was like 6 episodes in. We're like, well, that's all we know. Let's talk to other smart people.
Let's start interviewing people. And it's like, that has pretty much taken us to all kinds of interesting places. Why do you have some thoughts on that?
Yeah, where should
just
we go?
Keep doing what you're doing. I guess it's just I can give you some names afterwards.
We get ideas, every once in a while, but I think most of our value at this point is from interviewing people and finding out stuff that we don't know.
Yeah.
And generating interesting conversations from that.
Yeah.
Cool.
I think one thing that will be fun is to figure out how we kind of integrate podcast with Crested Butte events, with Winter Tech Forum, whatever.
Yes.
And we recorded a bunch of Winter Tech Forum sessions from a couple months ago, and we
Yep.
do need to work on getting some of those
I'd like
published.
to put those
but yeah,
out.
kind of figuring out. I think that's maybe the one thing over the next year that I want to figure out is like the better integration between what we do here in person and the podcast.
Because I really enjoy having the in-person events. They're just so fulfilling.
Oh yeah.
And I would like to have more, but I think my biggest issue is I'm bad at publicity. Because I used to, like, my first job was selling door to door a Fuller Brush company that was huge at one point, doesn't even exist anymore. And it was so awful that, pushing yourself on people, it's like, I hate the idea of pushing myself on people. So I kind of do a pull model, put out good stuff. Maybe people want, but I would like to hold more regular events up here, and because they're just so satisfying when you get people together, and that I like your thoughts there.
Yeah. Well, and the podcast is just kind of a taste of what we get to do when we get a bunch of nerds up here. So,
I actually didn't realize you were recording together in the same place. So add some context.
Right. Yes. Yeah. We live just a couple miles from each other.
Yeah.
It is. Right. Here in this tiny little town where every once in a while there's this interesting level of technical expertise.
Yeah. It's kind of wild that here in Crested Butte, tiny little town, Bruce and I and our friend Bill all live, and we get to work on our book. We've been for a couple of years working on a book about effect-oriented programming.
How's that going?
So we get to it's coming along.
It's evolving.
We have learned a ton by doing it.
Yes.
And we get together about once a week and work on it together. And it's been super fun, but yeah, I mean, so fun that we all live in the same town and can get together.
Do you still like the idea of significant indentation after all this time with Scala 3?
Well, I'm a Python guy from long back, so I considered that a big step forward.
I do, yeah. I mean, all the Scala code that I've written over the last, year has used significant indentation. Some of it has used the end experimental functor. The functor
fewer braces.
Fewer braces syntax. That one is I think I haven't formed an opinion about that one yet, but just the regular significant indentation stuff I really like. I just look at the code and I'm like, it looks really good.
Hey, you're preaching to the choir here.
I think there might be like an even fewer braces option. Maybe I misread that, but someone mentioned that there's fewer braces, which is already less braces than in Scala. I mean, the default is already less braces, fewer braces than in Scala 2. And then you have the fewer braces option. Now let's get even fewer braces so that there are no braces left.
So when I've used the fewer braces flag, the only place where I have braces is on imports, and that is it. And
you can get rid of those as well. We just like split the imports and then
you could, Those don't bother me.
No braces left.
Those aren't as annoying. But the like multi-line brace thing, it's one of those things where now I see code with it, I'm like, just recoil.
I'm still not sold on the idea. I'm like, it's a love-hate relationship because sometimes I'm liking it for small examples, but for anything bigger, I kind of miss having it. And it reminds me of Haskell actually, because I looked at the Haskell code with like functions on the top level. That's just like my file, and I felt like claustrophobic a bit because it was like there isn't enough syntax for me to hold on to. Like, what is this? This is just a pile of code, even though it's unrelated functions. It was kind of hard to.
So the interesting thing that significant indentation in Scala has forced me to do is to make really small blocks. And so if I'm ever at the point where I'm getting lost,
5 indents, you're going, what?
If I'm getting lost in my indentation, it means that I need to split something out. Yep. And that is a really good forcing function for, I think, cleaner code.
Yeah,
for sure.
Well, one of my issues, probably the main one, actually, I wouldn't complain if this wasn't a thing, is that copy-paste ability of the code suffers when you get that. Because depending on how deeply you paste the code into, you will get either the right behavior that you wanted, the wrong behavior which still compiles, or a compile time error which looks nothing like what you would expect it to look like.
Yeah.
So if
That's
that
true.
can be improved in some way, I will gladly accept the new reality, but so far I'm still not sold on it.
Might be a tooling.
Yeah, I think IntelliJ is our only hope.
Yeah, it needs to catch up on that. Yeah.
You're right. There is a trade-off there, and I do, when I paste in code, have to muck a bit with.
And that's true in Python as well.
Yeah. So there is a trade-off there.
You do. You have to look at it.
Maybe it's just just don't copy paste code. That's the answer.
Exactly.
Stop using Stack Overflow.
Copy and paste code. So let's just not do it.
Yeah. So the new pattern is just ChatGPT.
Unless you're trying to do a refactoring by like cut and paste within your own file, and that's a decent exception.
Yeah.
Well, Jakub, thank you so much. Super fun to talk with you. As always, from all your content online, I learn a ton, and we'll keep trying to follow along with where you're leading. I need to explore Smithy 4S and give that a try. That sounds super fascinating. So thanks for introducing us to that, and hopefully we get to meet in person sometime.
Yeah, thank you very much for having me. I really enjoyed this conversation. So looking forward to the future episodes. And seeing you live in person at some event, hopefully.
Someday,
sooner than later.
Maybe here in Colorado.
Yeah.
Or in Poland.
Yeah.
I'll need to take that heavy book with me to sign for you, Bruce. But
you're thinking in Java signed.
Yeah.
Nice.
Okay.
Thanks.
Bye.